Okay, so let's start with what we already know. We already know that to find volume, we can calculate the length times the width times the height. And we know that those three dimensions might change. If we turn the way the box is, the height might be at the bottom, the width might be up on the side. But as long as we have a length, width, and a height, three separate dimensions, we can find the volume. We also know how to calculate it. If we know three of the dimensions, the length, width, and height, we multiply them together, we can calculate the volume. We can even calculate the volume we can even calculate the dimension of one side if we're given a volume. So in this example, if we know the volume is 252 inches cubed, which we know is the unit for volume, then we can find the length because we also have the width and the height. We also remember from last year how to find area of a rectangle or a square by doing the length times the width. And we know that the units for area are inches squared or units squared. So what happens if instead of a length, width, and height, we're given 36 inches squared and 7 inches? That's looks to me only like 2 dimensions. That doesn't really look like 3 dimensions. So what do we do? First, let's think about what we know. We know inches squared represents the area of a two-dimensional object or rectangle. So that tells me that this 36 inches squared is probably the area of the bottom of the shape. And then that would mean the 7 inches squared is left as that third dimension. We could also figure out, if we assume the 36 inches squared is the area of this side, we could figure out a length and width. There's different possibilities. It might be 9 inches long, 4 inches wide. It might be 6 inches by 6 inches. We don't know exactly the dimensions, but we could figure out and get a list of possibilities. We also know the formula for area, which is to do the length times the width. Now this is interesting because length times width also appears in our formula for volume. So what if there was a way we could find volume by doing the area of one side times the height? So there's some official math language for the area of one side of a three-dimensional shape. We call it the base. So we have a new formula for volume, which is just doing the base, or the area of one side, times the height. This is, for example, in this shape, we see that there's 42 inches squared labeled on one of the sides. Now, the term base might be confusing. It might seem like it always has to be the bottom of the shape, but remember, we can rotate these shapes. We can move them around. So in this case, the base is appearing as the back of the shape, and then the 3-inch height, or the third dimension, is actually down here on the bottom. So to calculate the volume of this shape, we would do base times height, or 42 times 3, to get our volume in inches cubed.